Let's just make sure we are live. Okay, thanks everyone for joining. We are going to go ahead and get started. My name is Raj Iqbal. I'm the Chief Data Scientist and the one of the lead instructors at Data Science Dojo. And we are going to talk about our Large Language Models Bootcamp today. So we have been around for quite some time, one of the earliest companies in data science and machine learning upskilling. A lot of graduates, lots of companies on our portfolio, global presence. And we also happen to be the first bootcamp on large language models and generative AI in industry. So we are going to only focus on the large language models program today. So basically, the idea of the bootcamp is allowing people to give them the opportunity to learn the skills that are needed to build enterprise applications using large language models and generative AI. When we go and use ChatGPT, Claude, Bard, they work great, great tools, but there are some challenges when we start building enterprise applications. I think from our experience, the foremost challenge that we have is the regulatory and governance challenge. Many companies, we have a customer, we have a few customers actually who are using an LLM product that we have built. Think of that as your own ChatGPT, your custom GPT deployed within your own tenant. And a lot more, a lot more than what ChatGPT offers. We have built that, and the customers are using it. The foremost reason customers come to us is primarily for regulatory and data governance and AI governance type challenges. When you upload data to ChatGPT, if you allow your employees to use ChatGPT, there is a chance that that your intellectual property, maybe some PII, your HR data, etc., they might get exposed. And in worst case scenario, it may be used by some of these companies in building some of these models, and a whole set of issues can actually result as a result of that. But there are other issues, even if you are able to build these applications locally, which anyone can, of course. But there are other issues that you have to worry about, right? So now you have built this application internally within your organization. How do you handle all the issues around, the context window and how the token usage? How do you build an application that is cost efficient? How do you worry about the latencies of responses? How do you worry about hallucination? How do you worry about the correctness of response? And correctness is in a classic machine learning setting. Correctness could mean, well, if it is a fraud, if it is an actual fraud, the prediction should be a fraud. Correct prediction in that case. If the actual transaction was not a fraud, your model predicts it to be a fraud transaction, then that's a wrong prediction. But what does correctness mean in the context of a large language model? And there are different evaluation approaches. You would worry about, whether the answer is complete or not, whether it has all the factual information that was needed, whether, is it giving too much information, even if it is factually correct? Is it giving all the factually correct information, but not complete? So there are so many other nuances that you have to deal with when you're building an application that has some business implications. Whether you should use open source model or a closed source model, and how do you deploy them? How do you use them? How do you actually deal with the knowledge being outdated? How do you deal with the brittleness of prompts and so on? So there are a lot of business challenges that you run into. And in our bootcamp, we handle all of this. We actually have designed a very comprehensive curriculum. And the curriculum has been designed by people who actually who have built these products, enterprise products that are being used by some of the 50 plus, 100 plus billion-dollar companies globally. So, so this is not your hey, clone this Git repository and build a RAG pipeline on a single PDF file. You're talking about an infrastructure that can handle um, 10,000 files being uploaded at the same time, or 10,000, or pointing it to an API and building a RAG pipeline, or worrying about all the latencies and how the architecture should be, how to set up hybrid search, how to set up keyword search, or how to set up only semantic search, how to put guardrails and so on. So I will talk about all of these, but it is one of the most comprehensive curriculums. There are great courses out there, but the courses are in pockets. There's one course here on vector databases, one course here on embeddings, another course there on fine-tuning. We cover the entire stack in the best detail possible. And I will explain. I will show you the curriculum. I will show you some of the content that we have to give you a sense why we think that after attending this boot camp, we are very confident that you will be actually able to build an LLM product within your enterprise, whether you are you could be a consulting company providing building LLM applications for other people, LLM solutions for other people, or you could be a founder for a startup building a product. You could be an engineer, a dev manager who's building this internal capability, or you could be a technical product manager who's actually guiding these products and building and helping with the devs. You want an in-depth understanding as a product manager, as a technical product manager, to be able to build these applications. So we'll talk about all of that in a moment. So the bootcamp goes like this. Definitely a very comprehensive curriculum. All the mainstream LLM tools, libraries, and packages, will touch upon all of them with practical exercises. And then there is a comprehensive project with mentoring and support at the end of the day, at the end of the week. It's a 5-day, 40-hour bootcamp. We start. I will explain the entire curriculum. How we actually go through the curriculum one by one. You just have to bring your laptop. What we have done is when you set out to learn, how to do machine learning, or how to do build predictive models, in this case, how to build LLM applications, there are a lot of moving parts. You may need some GPU clusters. You may need endpoints for an LLM. You may need some kind of infrastructure to actually run all the library, all the code samples, and etc. So what we have done here is we have set up an infrastructure that is training ready, right? So you bring your laptop, as long as you have a web browser, we'll take care of everything else. And for any cost in terms of GPU clusters that you need for our fine-tuning exercises, anything that you may need for any token costs for inference, anything related to other exercises and other Python code samples that you need, you do not need to install anything. We have pre-set up environment that you can come in and start using and hit the ground running. So these are our partners. Thanks to some of the partners, I mean, they're providing us resources. They are providing us compute resources. And in some cases, we have instructors from these companies who are coming in and teaching at the bootcamp. So the next bootcamp is happening in it is actually starting on Monday, on December 2nd. So these are some of the partners in our ecosystem. Some for the next bootcamp in the December bootcamp, these partners are going to be involved. And in the past, we have had these partners. I mean, depending upon their availability, we invite speakers talking about real enterprise use cases for the respective problems that they are solving in industry. So I think what I'm going to do here is I'll go over this typical architecture of an LLM application, and then after that, I'm going to go through the curriculum. So if you look at this here, um, at the core of it, the very the core component of an LLM application, at the heart of this LLM application is the large language model, right? So it could be, the Anthropics of the world, and it could be the open AIs of the world, GPT-4, GPT-3, or GPT-4 Omni. It could be Llama 2, Llama 3, Llama 3.1. So you need some place to host them. You could be self-hosting them. You can get a hosted model in Azure, in AWS, in Databricks. But once that is in place, you need a lot more than just the LLM. It turns out that I often actually tell people that it is still 95% software engineering. AI is there, but you need to understand the concepts, but if you're a good software engineer, or if you're a good software, technical product manager, in general, you should be able to actually build these applications. Really the AI part is for the most part, it is used as a black box. And I will explain what that means in a moment. If you're using these LLM applications, another component, or maybe another significantly important component, is a vector database. You build a search index, a semantic or a keyword search index, on some cases, hybrid search index. You build that search index, and then combine your LLM with that search framework, commonly known as retrieval augmented generation. We will go and talk about RAG, or retrieval augmented generation, in quite a lot of depth. When you push your documents into a search index, very often you need actually to, if you're building a semantic search engine, you need an embedding model. So an embedding model is also a critical component. By the way, everything that I'm talking about, the reason I'm talking about this is that in the bootcamp, you will hear the theory of whatever I'm talking about in quite a bit of depth, and then also the practice of everything. So in this case, the embedding model, you convert your documents into embeddings go in a vector database, and vector databases have both your standard search functionality on top of the semantic search functionality using embeddings. And then you have other things like LangChain. How do you build a multi-agent system? How do you build the concept of memory and understanding of appreciation of history in your LLM application? How do you make an API call from within your agent? So you want to connect to the Google Maps API, or you want to connect to Bing or Google Search API. How do you do that? How do you create templates for your prompts, and so on? So that part is actually handled by LangChain. And LangChain actually has, you can see that, it is... LangChain is not the only one. We have Llama Index, and you can write your own Python code as well. But LangChain and Llama Index are by far the most popular frameworks in this case. Then you have to set up observability. How do you log things? How do you see the traces? If there was an error, was there a user feedback? How can you monitor that? How do you look at the metrics? How do you look at the latency? How many tokens are being used? What was the cost of inference? Then there are guardrails. How do you put guardrails such that a prompt that is toxic is not actually, or whether the prompt or the response, if they are not, they're against your policy, how do you ensure that there is nothing against the policy that is happening? Then there is deployment as well. I can keep going. I can spend a lot of time on this, but in general, we cover this entire stack to be able to we demonstrate or we actually practice and we learn and practice apply pretty much the entire stack. I mean, so whatever you may actually run into while building these applications. So what I'm going to do here is I will give you a curriculum overview. I will give you an idea within the next 15 to 20 minutes what we have in our what kind of content we are covering in our bootcamp, and then and what kind of labs we have, what maybe show you some lab samples, show you some slide decks, and so on. Okay. Let me actually make sure that you can see my screen. Okay. So let's actually start with so a common question is, what are the prerequisites? Really, if you are interested in building these applications, if you work in, if you have some appreciation and understanding of technology, you should be able to actually attend. I mean, and this may sound too good to be true, but when you see how we have structured this, how the labs are, really you will see how we have done it, how we have organized it, and then happy to take and answer any questions. So before you come in, the bootcamp, the language of choice is Python. So if you are not a Python programmer, we have some a 2 to 3 hour tutorial that you like, very high speed tutorial where we bring you up to speed with the basic Python concepts. And once you have done that, when you come in, on the first day of the bootcamp, we start on Monday. In this case, the next bootcamp is starting on Monday, December 2nd. And the bootcamp is going to be, some people attend in person in Seattle. Other people, they are located remotely. So some people, they attend it remotely from wherever they are, from the comfort of their home. So you can enroll in the same boot camp, the same interaction. You can see people in class. People in class can see you. Sometimes it ends up happening that online attendees, they tend to be actually far. Sometimes they are actually more engaged than the in-person attendees. I mean, there has been one case, but in general, it's a very interactive experience. So we start on Monday. On Monday, we start with the general high-level overview of the entire ecosystem. What is an LLM? What is a prompt? How does a prompt work on an LLM? Very simple idea. Why do you need embeddings? I mean, what does an embedding mean? Why do you need a vector database? And very high-level explanation of why do you need a vector database and why do you need embeddings. Then we go and talk about the risks and challenges when you're building these applications. How do you customize your model using fine-tuning, RAG, or some kind of hybrid method? And within the first 2 to 3 hours, you have a fairly good understanding of the end-to-end ecosystem of what does it look like? What does it mean to actually use an LLM application? Once we have done that, we have this session on the attention mechanism, text embeddings, and transformer architecture. And the way we do this is you can see that we start with, so even if you don't have any background at all, we start with the very basics of why. I mean, what is discriminative learning? What is generative learning? Then what is a transformer? What does it mean to use a transformer? And then we slowly, gradually actually explain the whole idea of attention mechanism. We talk about attention mechanism, and we build it very slowly but surely. We build this whole momentum where you from intuition to actually you are able to understand what actually this whole transformer and attention business is about. So you can see dot products, etc. Of course, I cannot tell you, I cannot explain everything to you, but you can see that we talk about multi-head attention here. What does similarity mean? What are similarity matrices and really get that geometric and algebraic interpretation of what does all of this really mean. Then we have practical exercises. Then we move on to vector databases. Once you have the embeddings, what do you do with those embeddings? Well, we store those embeddings in a vector database. So what is a vector database? So if you look at this, we go and start with drawing parallels between standard vector database to your relational database. How our vector database is different from relational databases. So if you look at this, what does a query look like? And what does a vector database really do? And then we talk about different types of searches, vector search, semantic search, hybrid search, filtering, and why it is needed. We talk about different indexing approaches, most notably HNSW. I mean, how do you actually, when you have hundreds of millions of embeddings in a vector database, how do you retrieve these embeddings as quickly as possible? So you can see that this session itself, more than 100 slides here. In this session, we spent about 3 hours explaining how does a vector database actually work. Very detailed session, ideas around chunking, what happens to chunk, individual chunks, how do you add metadata to your chunks? I mean, why is it important to add metadata to different chunks and so on? Then we move on to exercises. If you look at this here, so we do 6 to 7 exercises here. So we start with a simple vector search. What does it mean to do vector search, right? So, well, now you will click here, and everyone, each of the attendees gets their own instance of this lab environment. Any changes you want to make, any new code samples you want to create, you have persistent storage with us in our lab environment. Now you look at this. I'm creating a data set, importing the data, querying the vector database, and so on. Now, then we go to similarity search. Then we go to hybrid search, and hybrid search is that when you're combining both the keyword, your standard traditional search with your semantic search, right? So if you look at this, loading some of the questions, if you look at this here, I will go and open this file. Let's look at this here. Here, I am going to here. So we load this file, a small data file. We import that. I will import it in a vector database, and now we'll set up a hybrid search engine. You can see that there is, we are showing you different query parameters. So I think I can run it. I hope this, and then you get the a running instance of a vector database, right? So you don't have to worry about setting up your own vector database. Yeah, I have to, let me see, did I run this? Okay, so I think this VVR server is not running. This is a vector database. I mean, if this was running, I would have been able to show you. But you can see that what we do is we give you these examples of how do you perform a hybrid search? How do you search on a specific property? How do you create filters and facets in your vector search index? Then generative search, and then you have vector compression. What if you have too many vectors and compute and computational resources, they become a challenge. So how do you compress your vectors while maintaining accuracy? Then how do you set up semantic caching, just like you have regular caching in software? Semantic caching is in scenarios when you expect that very similar queries are going to hit your search index. How do you make sure that you're not actually generating those tokens again? You cache the results. What is the capital of France? And tell me about what is the capital of France? That's a question. What is the name of the capital of France, right? So these two queries, the words are different, but the intent is the same. So semantic caching actually, helps you save on compute and infrastructure cost, inference cost by caching the similar results. Then we set up a very, very basic. Now people are when people are um, by this time, and this is day two, by the way, we are already in day two, I should have mentioned. So by lunch on day two, you're very familiar. You're very familiar with the idea of RAG, the general overall ecosystem. And now Verba is, think of this as a very basic uh, a RAG application. So you go and build this RAG application using Verba, and we give you, the infrastructure where you can actually deploy this Verba application. Now, there is so BB8 is our partner here in this, helping us with the curriculum and then also delivering the curriculum and also providing the infrastructure. Then Neo4j, they are also our partner in this whole thing. Then we talk about how can knowledge graphs actually help you in improving RAG. So we have a session on graph RAG. Adam Cowley from Neo4j, he actually talks about the whole idea of graph RAG. So and we finished that this this discussion on how can we improve, how can we reduce hallucination using graph RAG. And then we move on to, let me actually go here. Then we move on to LangChain. We spend almost, I have to say, we spend about a day on LangChain, 6 to 8 hours. And we cover LangChain in as much depth as possible. I'm not sure how many of you are familiar. Some of you may be familiar, the fact that you're here. So I'm assuming that some of you are already familiar. So we start with Model I/O. We talk about why do you need templates? Why do you need example selectors, right? So in this case, for instance, if I launch it, so you will see the lab comes up. So I cannot click on each of them, but basically that's the idea. The labs are already running, all the dependencies, etc. They are already installed. And what we do here is we discuss why prompt templates are needed. Once you understand why prompt templates are needed, well, here is how you create a prompt template, right? So, and then if you look at this, I'm going to run. And even if you're not the best of software developers, if you know how to read this, we actually discuss what does chat open API mean, what are the other libraries that are there, what is prompt template, right? So so what are some other libraries that are available, right? So if you look at this, you can see that we go through them, really explain in a manner that it makes sense to even some users who are somewhat non-technical, right? So and then this is creating a connection or an instance of a GPT-4o. And then I am, running this prompt template. And then we talk about we talk about what does this mean? What does this total tokens mean? Output tokens. What does this this whole response mean? And how are you going to build an LLM application using this? And now imagine now retrieval. How do you connect your application with different types of data sources? Google, Bing, Dropbox, SharePoint, Salesforce, HubSpot, really any possible data source. How do you do that? How do you create chains such that your LLM application, it is a series of function calls as opposed to a single function call. Let me go here. Maybe I can show you one more example from chains here. It's coming up. And I'm going to run it. You can see that I'm actually now using chains here. The same thing, this API key that I'm pasting, everyone gets an API key for their usage during the bootcamp. And then we run it. And then if you look at this, this is an example that we have created a chain. First, you ask this, if we ask the user, okay, which suggest an area. And we have set up this prompt template where we are talking about your job is to come up with a classic dish from the area that the user suggests. And now the next part of the chain is given a meal, give a short and simple recipe on how to make the dish at home. And the third part of the chain is given the meal, a suggested dessert that goes with that meal. And then when I go ahead and run this, basically we go through this entire sequence and explain. One more thing is a lot of these things. A lot of these things can, we can go through this process, but then we go back and show you how we leverage this in a practical application. What does it mean to actually have these chains? And how would you use it in a real application? Then, this is the router chain and so on. Then we talk about memory. How do you build the concept of memory in your agent or your LLM application? How do you create multi-agent framework? How do you build this agentic framework? And an agentic framework, we cover LangGraph as well. So we will be talking about LangGraph. How do you build more complex agentic workflows using LangGraph? And a whole lot. I'm sure I'm missing something here, but this is, maybe I can just working with LangGraph. I click on this, and LangGraph is going to be, you can see that we're talking about the agent state and nodes. How do you create these nodes? And for those of you who are not coming from a programming background, but are coming from product management or the background, I can assure you that most people they are just fine because the code is already there. You just have to understand how things are flowing. But for those who are more coding savvy, they should be able to uh, modify this and build applications. So one thing is that, if you're a product manager, you will leave as an LLM and Gen AI product manager. But if you're a product manager professionally, you're not going to leave as an LLM application developer, right? So you will remain, the role that you have will remain the same, but now you have added a very good, thorough understanding of LLM and generative AI landscape. So this is a common question, but the amount of code that you see, it should not deter you from attending the bootcamp because really, you have to run. If you look at this, I'm essentially just running this code. We discuss the code. Hey, what is this doing? What is this? Tick token encoder. What does this do? And so on. So we actually explain the code And as long as you understand that part, I think you should be okay. Um, then I will go back. LangChain is done. We talk about building a basic semantic search engine. We talk about really the challenges in advanced RAG. I mean, how do you deal with when you're setting up a RAG application? How do you really deal with different challenges in RAG? I mean, so how do you deal with chunking? How do you set up chunk augmentation? How do you understanding intent? How do you mitigate hallucinations? How do you decide how many chunks should be there? Then what embeddings and how big should the embeddings be? Whether you should compress vectors or not. So there are a lot of nuances there that we talk about in a lot of detail. We also talk about fine tuning. In fine tuning, we go through the idea of fine tuning, transfer learning, in depth quantization, low rank adaptation, QLoRa, which is a combination of both, and then we give everyone gets a GPU cluster where they can actually fine tune a Llama 2 7 billion model, a 4-bit quantized model, and we compare the one with unfine tuned or with a model that is not fine tuned. Um, um, we also go through the details of evaluation. Evaluation is something that may not come in as the first thing to learn, but it is incredibly important for you to know how to evaluate your large language model application. So we start with the standard machine translation type metrics, all the way to things like perplexity score and RAGAS, metrics around evaluating your context and evaluating the generation responses. I think there was something that I wanted to say that I'm forgetting now. Yeah, and we also cover the data sets and which data sets are best in what scenario. So for instance, if I go down to evaluation, if you look at this, once again, same thing, practical exercises, right? So because a lot of this material, I mean, one YouTube talk here, another deep learning AI course there, one Udemy course there. I mean, a lot of these things are fragmented, but what we have done is everything is coming together. In 1 week, you have a very solid understanding of what does building an LLM application entail. So I will show you just one example here. If you look at this, I'm talking about evaluation using RAGAS, and then when I go here again, the lab is there, loading and splitting text documents, creating embeddings, and setting a vector store. We go through this step by step, and the labs, by the time we get here, by now you absolutely clearly understand what a vector store is, and you know what is happening here. You know what a prompt template is. You know what a chain is. And so really, initially we take it slow, but later on during the week, you can see that a lot of things, they are coming back and you're putting all of the context together. And if you look at this here, we have built these. We have created this lab to solidify your understanding that the things that you learned in theory, now you're applying it. What is context precision? What is context recall? What is faithfulness? What is answer relevancy? And so on. We talk about observability and guardrails and monitoring of your models. How do you put some tracing and logging and monitoring on your LLM application? We talk about that in quite a bit of detail. Then we also talk about deploying your fine-tuned model. That is another session that we have. And then finally, on the last day of the boot camp, we show you how to build your own LLM application using using different tools. And then once again, you know, that part is that we give you boilerplate code, and from there you can actually you can get started, and then you have exercises. Now add this chain, add memory to your application, and do this, make it multi-agent, make it agentic, and so on. So let me go and see if there are any questions. Okay. Okay, Harold, your question is how much to attend the boot camp you're referring to? The boot camp is $5,000, but I think there is, depending upon availability, depending upon the seats we have remaining, I think right now, don't quote me on that, the price at the moment, the price is around $3,700 or $4,000. I'm not sure. Please check the website. I think go to the website and the team can actually post a link directly or set up a call with us, and we will be able to let you know. Then there is more questions. What is the cost of training if we are joining in from India? There is no difference in cost because, I mean, our cost of doing business is the same, but happy to talk to you, Manny. Please, feel free to set up a call, and then happy to actually talk to you. Okay. Yes, the recording is going to be shared for sure. Okay. Let me see. Okay, there are some comments there. Can you share the link to the Jupyter Notebooks? No, these are behind a login. We cannot share the links to the Jupyter Notebook, but if you're looking at something specific, we are happy to, if you can set up a call, we will be happy to actually show you the notebooks. Let me see. Do we have, and there is in the Q&A tab, I think, Carol, I have already answered your question. It's okay. So I think, let me see what I have remaining here. We have gone through the curriculum already. As I said, I mean, knowledge of Python programming. You can just go and, if you have some background in Python, you should be able to actually follow everything in the content very easily. This is roughly the technology stack that we cover during the bootcamp for different exercises. So the final project, for instance, it is deployed in Hugging Face, and I believe it is Streamlit, but we do use some Hugging Face there as well. And you can see that this is roughly the technology stack. And this is just, the high-level idea. What is the content? What is the content that we are covering? So, and then we also have sessions around, our own learnings while building a product. I mean, what should be the architecture? How should you set up your search index? How should the microservices be set up, and so on? So it's really, really a very carefully distilled information that we share as a practitioner. Let me see, attention mechanism, vector databases. We talk about all of these things. There is semantic search, prompt engineering, fine-tuning. We talk about that. Then we have LangChain. We cover LangChain in as much depth as possible. We are probably one of the most comprehensive course discussions or treatments of LangChain out there. Multi-agent applications, we talk about this. Monitoring the guardrails is there. Advanced RAG, right? So really, I mean, building a RAG application. So I saw a comment, yes, I mean, yes, you can find this information online. But really, if it was that easy, then everyone would be building LLM applications, right? So with all due respect, right? So Yes, yes, you can find a lot of this information online, but the way it is, how it is organized, how it is, how we connect the dots, how the exercises are set up, that is what makes all the difference. Okay. LLM evaluation, I've talked about it, and building an LLM application. Finally, that is there. These are some of the instructors that we expect. I think all of them are confirmed except one, but this is what we expect. Next time, I mean, here are, I think, I'm sure you have seen these testimonials. I think the team was actually putting these links there. In the chat window, and I'm assuming that on the social media if you're watching the live streaming. But I mean, these are our partners and customers who actually have attended in the past. We have had people travel all the way from, well, as far as Australia and the Middle East and Asia and Europe. They have been traveling to us. Many people attend remotely. Some people, they prefer in person or in class learning. So if you look at this, these are all the these are some of the companies that have already attended our training. So, and these are, you can see Microsoft, Google is there, Aramco is there, and Starbucks is there, Fidelity is there, right? So these companies have actually attended our training. So we have been doing this for a little over a year already. The next bootcamp, Seattle and online in parallel. Some people attending in person, others attending remotely, but same learning experience, same discussions, and the same curriculum. We're making it a bit easier for people who cannot attend who cannot travel for one reason or the other. Okay. So if there are no other questions, let me just give it a moment. And if there are any other questions, I'm happy to answer. Otherwise, we are coming to an end to the of the training, or rather this info session. Okay. Thank you so much, everyone. I hope I will be seeing at least some of you